Hey, I think we're live. I
Hey,
got distracted one more time. Hello, everybody.
hello.
Hello, Ben.
Hey, Bill. How you doing this week? I see some
Ah,
people there. There's Mondo 8 bits in Menace 312, and we're definitely live. I'm going to mute that. So, what gives? What's new?
well, my VoIP provider is being DDoS attacked. So my business phones are off the air, which includes my two-factor authentication. so so it's an exciting day here at the ranch. Oh, we also had a chicken die yesterday. It was very sad.
Oh,
No, normally they don't die in the middle of the day. This one did. So it's probably just old or it was impacted with an egg. But normally they
oh.
kick during the night just due to the laws of statistics. But
How many chickens do you have?
well, we're down to about 7 or 8 that are running around, but we've got a batch of about 8 or 9 ready to release. So we got a lot of chickens. But
Ready
the
to
old
release
batch is
means they're
old.
they're really old. So, and one of them was
Yeah,
the one that died.
yeah. The
So
old
I'm
ones
sure.
are.
Yeah. I was just going to
So
say, I'm sure living with you as your animals, they probably had a really good life.
Um, our entire homestead here is based around these dang birds. I have no grass in my yards. The ducks ate every blade of grass during the winter, every single blade. So it's like now I'm out there trying to fix erosion problems, things like that, just so my son can walk around with the duck under his arm. So
I love ducks. I
so
think
how's
ducks
your
are so
weekend been?
awesome.
Your week?
It's been very stressful, but for reasons I can't discuss easily and or wouldn't discuss in public, let's say. Um, but we all live, and we're all in this. We're all in this. There are people in parts of the world. I've got family back home in Australia who are.
Whoop, we lost you there. Oh, you're
Oh
back. You
yeah,
you said
yeah.
you said you
The
had a
algorithm.
family in Australia.
Yeah, the algorithm was listening to me and decided to chop up my call because I was complaining about lockdowns or something. Anyway, Skype does that. Don't be surprised. Don't be surprised if your conversations on every device are not listened to by people, of course, but
But
listened
they're
to
monitored.
by
Yeah,
algorithms. And
right. Which then decide what
there
to
may
sell
be
you next.
That's right. That's right. It's all in the name of targeted advertising, right?
Right,
And giving you what you want.
right.
And
I just remember I had an early Gmail account that I didn't use for main stuff. I used it for side stuff, and suddenly I started getting advertisements for leather products, and it related to an email I had sent. So literally, the email I sent suddenly now the advertisement was tailored to me.
it's kind of, yeah, or you be. I have not had this experience, so I can't vouch for its validity or not. But it's a funny thing to discuss and think about and joke about right now. But it's also a little bit scary that
Oh,
people
it's
have
real
said
scary.
they had a conversation verbally. Their phone was in their pocket. They were not on a call. They didn't have any apps open.
I've heard
They
that.
had a
Yeah,
conversation with a friend verbally about a particular, I forget what it was, something like a particular model car. And next thing you know, they were getting targeted advertising about that car. It's like, come
right.
on, guys. Come on. Google, Amazon, enough with the creepiness. It's
Well,
like,
in the
and we know it's
Constitution,
not humans eavesdropping, it's algorithms. So,
right.
they mentally, ethically justify it by saying, look, we just made this thing that would help you with what you're looking for. And it's like, yeah, I get that. And to an extent, it is helpful, but it's gone too far.
Well, there's going to be a test for our Constitution at some point because the framers would not have worried about digital data interception.
Mm. Hmm.
So yeah,
So
Chris says in the chat room, 1984 was a warning, not a bloody manual.
Exactly. Thank you for saying that, Chris. And those of us who are, Bill, you're old enough. You've read 1984. I've read 1984. When I was in high school, it was required reading for this
Yeah.
reason, and they've
Hey,
taken
I
it
was
out.
alive in 1984.
They took it out. It's not required. That and Fahrenheit 451 are not required reading
Right.
anymore. And I disagree with that. I bought those books and made my own kids read them. But this is,
Yeah.
I mean, I am not going to force my views about certain things, on other people. That's up to you. You're your own agent, right? And you get to decide how you want to live and all that. And I will love you for who you are, no matter what. And I think that's really important that we embrace that attitude. So I say all that to say I won't. I try to avoid discussions about certain things going on right now. And at the same time, it's like, but just be informed at least. Make sure you're aware of how all this stuff is
Right.
it's permeated our lives.
Which is easier for younger people than it is for the elderly. I mean, this is, picture your grandfather trying to figure out his phone, let alone what the phone can be doing nefariously.
Yeah, my dad, I guess my parents are old enough. They're early 80s, and they hate all the devices, not because they're worried about what might be spying on them, but because they just don't understand them. It's not how the world, like they had dial phones,
Right.
and they had pens and paper, and they didn't grow up with computers. It was your generation that built the first computers, and my generation that first grew up with them.
Right.
And
Yeah, when I was young, there were no computers. There was a TV set. That was technology in the 70s. Was a TV set, and then, lo and behold, the Atari Pong thing came out, and we were like, something to put on the TV set. It was pretty cool.
Yeah, TVs are now interactive. Whoa.
Right.
So,
TVs are listening to you, which we always laughed at, right? We always said, no, people are not listening to you through your TV set, and lo and behold, nowadays, of course, China can listen to you and see you through the TV set if it's got a built-in camera.
Yeah, well, that's 1984. Exactly to Chris's point. This was predicted in the 60s when George Orwell wrote. Was it the 60s or late 50s he wrote that book? Late 50s, early 60s. He's like, there's telescreens everywhere, and you see what's happening, but they're also watching you, and they can tell you what to do.
Right. and you had to act like they were always somebody watching live. So you would open your your bag and show the camera when you walked in the house and stuff. Publication date, you're not going to believe this, 1949.
There you go, even earlier.
Yeah, I would not have thought the 40s.
Yeah.
What a visionary.
Incredible, just brilliant.
Yeah.
So, and here we are. We have to stick stickers on our laptop webcams. Not that I do.
I do. I have electrical tape on mine.
The laptop webcams now, like this one that Autodesk provided me with, actually has a built-in camera shutter.
Okay.
So
there you go.
The computer manufacturers realized, there's an additional feature we can add that is a selling point.
Right. There was a picture of the guy from Facebook, whatever his name is,
Zuckerberg.
and his laptop. Yeah, and you could see on his laptop he had taped over his camera and his microphone. So it's like, the guy that knows better than anybody knows. Yeah.
Totally. So anyway.
Hey, so we had some requests last week for some C128 type things, and I thought I would answer them this week.
Yeah. This is cool. And what are we looking at there? I see you've got Altium's cam viewer open.
Well, I was going to start with the Z80 Clock. We can start with Altium. Let's start with the Altium.
So why in the cam viewer? This is the C128 PCB design, but that was originally done before Altium even existed or Protel existed or any other desktop CAD. So
or before Ben existed, right? Were you alive in 80?
Yeah, I was born in 74.
Oh, okay, okay.
So I was already getting into electronics by then. I was already learning about resistors, caps, transistors, diodes, and LEDs, and making astable multivibrators by 1983.
Yeah.
I got my first
I remember my
soldering
stable phase. Yeah.
I got my first soldering iron at Dick Smith Electronics book and kit from my older brother, who was a tech for ABC Radio in Sydney. He bought me that as a birthday gift in 1983. So that was December 83. That's when I started. And I turned 8 years old.
Wow, okay. I used to hang around a radio station.
Actually, I must have been turning...
That was part of my exposure.
I must have been turning... It must have been December 82 because I was 8 during 1983, and that was the year I remember being 8 when I was really learning about electronics for the first time.
Right.
So
right.
December 82, got my first soldering iron.
Yeah. Yeah, I used to hang around a radio station, an AM/FM station in Marion, Indiana, and I just remember watching. They had the big cabinet which had the power amplifier, and up near the top, it must have been a window because, the doors had to be shut for the interlocks to work, for the high voltage interlocks. But you could watch the pulsing, the secondary ionization coming off the RF amplifiers on the AM station.
That's
and
cool.
Boom, 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 boom. Yeah.
Yeah, I used to look at that in the back of my tube guitar amp combo, that when you had it cranked up, the output tubes were EL34s, so big output tubes, 4 of them, 100-watt power amp, and they're almost a vacuum inside, but never quite a perfect vacuum.
Right.
So it's just enough and enough voltage in there.
And mercury, or getter in there, getter fumes.
Yes. And so, but there's still a little bit of purple corona discharge in them.
Right.
So you can see
my favorite
this
tube,
faint purple glow on the outer edges of the envelope, the glass, and inside, of course, you have the amber glow of the heater. So you get this beautiful, rich color. I just love it. Anyway.
That was before LEDs, where you could light the tube up like they do now for Nixie tubes and whatnot. So my favorite tube was a 6BQ5A.
Oh, I know those. Yeah.
Yeah, EL84, but I'm trying to remember the power handling. They were not 100 watt. They were only like 15 watt or something like that.
Well, those are used by the Vox guitar amp. So Vox AC30 is a 30 watt Class A amp, and they have 4 EL84s, which is the 6BQ5 is the American numbering of EL84 is the European. So EL84s, they have 2 driver tubes. Well, it's push-pull, but they're biased in the Class
It's got a phase inverter and yeah,
they're biased in the Class A. But so it's that'll give you 30 watts. 4 of those will give you 30 watts, whereas 4 EL34s will give you 100 watts.
So I am looking at a 6BQ5A tube for sale on the internet.
Show us. Can you share the screen?
Guess how much money it costs?
Well, they still make these for guitar amps and sell them at Guitar Center. So I would normally buy a set of 4 matched. Yeah, that's a rip-off.
That's a rip-off. That's $400 for one. It's not even matched or anything.
No, I'd buy a matched set of Ruby tubes at Guitar Center, get 4, which are all matched, for just over $100, maybe 130.
Right, and that'd be new. This one's used even.
Yeah, there are
audio.
That's all right. That happens because there are audiophiles who have more money than sense and don't really know electronics.
Yeah, I was going to say common sense. Yeah.
They have more dollars than sense.
So what happened last week was somebody asked about these mounting holes that are in the 128. And so this is a board done by Johann Grip. He reverse engineered the C128 by literally depopulating a C128 board and then photocopying it and then tracing the, whether electronically or manually, tracing the different traces. Now, I shot this. He sent me the Gerbers, and I shot it in black because I was trying to make something cool. But unfortunately, you can't see the traces here between these two holes. But so I've got a Gerber I'm going to show you in a second. But the thing about these holes are they limit the data that I can get from the right-hand side to the left-hand side of the board, and yet they're not used in a standard C128 computer. Those holes were there so you could use the same PC board for either the 128D,
which
or
is in the desktop, right?
Right. It had a built-in floppy drive, and then there's the flat. They call them bread boxes, or so I call them the doorstop. The big flat one used the exact same PC board, so even the one that went in the regular C128 had room for a second reset switch, because there was a reset switch for this main board and then another reset switch for the floppy drive. So there's a little bit of circuitry here that was unique to just the D, but most of this is 100% identical between both models. And we ended up with these holes because of support posts in the C128. So they had to come basically right through the board. So thank goodness we figured that out before we even started, or we'd go, hey, put this in the 128D, and it wouldn't have fit.
And the support posts were needed because why? Because they knew people were going to sit the monitor right on top of it.
Set the monitor, yeah, right. Absolutely.
Okay.
So here's
we're seeing
the Gerber.
Those black holes there and there. So that's cool. But it looks like your top layer's got the horizontal bias routing. So was this auto routed?
Oh no, this is all hand routed, and in fact, it's in the book that just came out about the 3 days it took us to run the last 20 routes. It was all hand routed, and what we're going to find out is that it's as dense as we can make it. And see this hole here. You can't see my cursor because for some reason it's showing up black on black. But this hole, let's see if you can see it. This blank spot in the top and the blank spot in the middle. Yeah, but those are those holes that are the holes I showed and stuck my fingers through. And what that means is between here and here is a limited number of traces between this hole and this hole. And it was something like 23 traces fit in there. And all hand routed. And that's the main reason that when we had to put a wire on the C128 board for the reflection we got, first off, probably had a real nasty trace. But second, there was no room to put a trace or add a trace that didn't mean moving lots of traces. And if we moved lots of traces, we might have made more reflections. Who knew? So I knew that the wire fixed it, but I had to, it was the devil I knew versus the devil I might create times two.
And so this board was done in, it wasn't hand taped. It looks like it was done in CADs. So yeah. SciCards was what did that run on? Was it mainframe? Or
it ran on our VAX. It ran on a VAX 11750. So, matter of fact, let me see if I can find the bottom layer for you here, because you mentioned the bias. So, you'll see we're just as crowded in the up and down, or vertical for some of you out there. There's areas here where there's no more room for a single trace to get through some of this stuff here. It's unbelievable that it fit. But yet the guys were going to stick with it till they got it to fit. A guy named Terry Fisher, Claude Gouet, Paul Rubino were the three main guys. Matter of fact, their initials are down here in the corner. I doubt if I can zoom in on it.
Your mouse will to do it.
But this is in the reverse. But it says R.I.P. Herd Fish Gouet P.A.R., which is Paul Rubino.
Why the R.I.P.? You're not dead.
Well, we were after 3 days, 24 hours a day. We worked throughout the weekend, and in the book I call it the weekend of tears, right? Because the full story is that the bosses left for Italy for a business meeting, and the third or fourth in command decided he was now a big boy and should don his big boy pants, walked around urinating on anything that he could reach, and his exact words were, "This 128 has just gone on for far too long. We're going to give priority to the other projects now." So they wouldn't let me finish the 128 the month after the CES show so that we could hit our marks. We still had to get it in production. We had to be starting to produce in March. We had to pass FCC in February, which meant we had to be done in January. And that's only because we were on an expedited FCC path, which meant we couldn't move any parts around. We could only move traces or add transistors. So some of my fixes I did by adding transistors because it was a FCC Class 1 permissive change, it was called. So they created this problem, and then the bosses get back, go, "What the frack what happened here?" We all just pointed at the manager, he did it. And so it didn't help by pointing at him because now we had to work. So we started work on a Friday and we worked till Monday morning. And they did 3 shifts, but I had to be there for all 3 shifts because they would need to ask questions. So I just lived in the plant for those 3 days. Actually, it was 4 days because then Monday happened.
So you sleep in your chair or on a couch somewhere when
I had an air mattress. I had my military air mattress in the CAD room, which was so cold that I slept in my military sleeping bag, and then I had my coat draped across me, and I slept with one foot out. And I told him, if you need to wake me up, just tap me on the foot. And I would. I'd sit up. I wouldn't even wake all the way up. I'd wake up to dinosaur brain, but dinosaur brain, when Bill Hurd was young, understood trace routing. And I'd go, no, let's do it here. And then I'd fall back to sleep until the next time they woke me up.
This is a lesson for, for Wes and some of the other, and Nick and some of the others here who are younger. Work your butt off while you can, while you're young.
While you can, yeah. Because then body parts start falling off and, all kinds of things.
You asked me how my week was. I'll just be honest about something here. I had to pull an all-nighter this week to get something done that...
It's not as easy as when you're younger, is it?
It was so hard, and it takes days to recover. It's not like it used to be. Anyway.
Yeah, I used to not need a recovery period after a 24-hour. It was a buzz. My dad even asked me, why, how, what? I'm like, well, Dad, first off, it's kind of a buzz.
Yeah, well, that feeling of elation you get when something actually works and you've been through it and it's, and it's, you actually got it to function and you've conquered. It's like, we all need that. I think as humans, we have been, my view is we've been created, but whether you believe in that or not, it's like we're born with a need to overcome some challenge. People who
Matrix
live
theory.
It's also Maslow's hierarchy of needs. If you're at the base of the pyramid, if you don't have food, that's your challenge. And once you've solved that, then you go on to the next challenge, and eventually you get up to this challenge of, well, what am I even here for? But any way you look at it, it's good and right for humans to have difficult things to overcome, puzzles to solve.
Right. A lot of good science fiction written about that.
Yep.
So probably non-science fiction too, but I'm a science fiction.
Well, did you see the movie Apple and Pixar put out when Steve Jobs acquired Pixar? One of the other first movies they put out after Toy Story was WALL-E.
Okay.
Did you see WALL-E?
I love WALL-E. Yeah, no, that's a great movie.
It's one of my favorites of all time because you see the people on that spacecraft who've gotten away from the funk in the Earth's atmosphere, and then several generations go by and they're all just... They can't happy.
Walk.
Yeah, they seem happy, but they can't hardly do anything, and they're like wondering what their existence is actually even about.
Well, and there was still some sense of economy going on there. They still had to like purchase their blue outfits when blue became the new red and stuff. They
Right.
and they were still being sold drinks and upsized and all this. So how's that work when the company owns the ship and everybody in it for all practical purposes, but they were still being sold stuff by and large.
Yeah, well, and it's like, why do you even need the people?
Right? Right?
What are they there
Right.
for? Once your AI has reached that level of sophistication that it's like, what are the people just your pets now that you take care of for fun? Maybe that's
Right.
what it is. Maybe we're all just pets.
Who knows? So
Anyway,
one of my favorite scenes in Wall-E was where there's an AI typing on a keyboard. So it's using an output device to input characters, and they're ones and zeros. It's typing ones and zeros into the screen.
that was always the classic problem I had with sci-fi, and particularly Star Wars. You know, you have humanoid robots that are actually using human machine interfaces to do stuff. R2D2 was the only smart one that just plugged straight in.
Right, right,
Anyway,
right. And,
Anyway,
and
so-
supposedly, I've been watching Adam Savage's talks. It's called Tested on YouTube. And he was talking with some of the people that made the R2D2s. And it's plural because there were several of them depending on the shot. And there was one that was meant to show that data plug. There was one or two R2D2s that were constructed with the data plug operable, So, yeah. But not all R2. He said they weren't even the same size. You just can't tell. They were approximately the same size, but they were different size models. So, right, you couldn't even get the circuit board to fit in R2D2. Well, you could, but there wouldn't be room for much else. We were talking before the show just the absolute size of this thing. And this was this size because the monitor fit on top. So I was telling Ben that the size of the PC board was actually determined by the mechanical engineers who first did the case and figured the case with a monitor on top and then laid out the outline of the PC board, and then they said go. And we grabbed the outline of the PC board and ran for the hills with it.
Even in the 70s and 80s, ECAD, MCAD was a thing. They just didn't do it in software.
They didn't do it in software. No, it was a hand drawing. And I got taught drafting in high school. Did you happen to have a class that taught how to draft with the T-square and how to do call outs and everything?
Yeah, not in high school, but in first year bachelor's degree, we learned technical design and drafting, and we were using AutoCAD. We were using AutoCAD, but before we did the AutoCAD assignments, we learned all the stuff about drafting, and we did some things by hand first, and then we had geometric dimensioning and tolerancing, and then we got into AutoCAD, and then we had a huge assignment where we had to design a thing.
Right.
So,
and I was taught it in 7th or 8th grade. In junior high, we had a school between 6th grade and high school called junior high. I don't know if you had those in Australia.
We just had the British system had the equivalent of elementary, but it goes up to the 6th grade.
We had
called
that.
Primary school and then secondary school. And in secondary school, we had high school is 7th grade through 10th, and then you could leave and do a trade, or you'd stay on for 2 more years and do senior high school and get your high school certificate.
Oh, interesting.
That's like doing your SATs to get placement into a university program. Excuse me.
So we had 7th through 9th was what we call junior high, and then 10th through 12th was our high school. Yep. And you had to finish. You didn't have to finish high school, but there was no branch out for the trades. You were expected to finish high school, even if you were in a VOTEC program.
Yep, same as what my kids do now.
Yeah. So that's the old C128 board there, and those holes where they were a necessary evil, but they were an evil. You can see that little area between those two holes, man. That was the big challenge. Matter of fact, we called this area the Data River. Unless we were speaking with Japanese, because we'd all be hunkered over the same board, and our accents we would pick up from each other, and after a while we started calling it the Data Liver. And it was just, and it wasn't making fun of anybody. It's just we spoke in ways where it was easy to understand each other.
Yeah.
And so we start to say kohi instead of coffee, just because you can both say kohi,
Yep. I actually found myself doing that after moving to the States and doing technical support for Altium for the first couple of years. I was basically by then helping run the support team, and I got so sick of repeating myself with my heavy Australian accent on the phone with customers that I ended up I didn't lose my accent, but I changed the way I was talking with some words pretty soon because I've just thought it saves time.
Right. Well,
So-
I tell people I learned English when I moved to the East Coast because I'm from Indiana. In Indiana, we talk like this, and it's not even an accent. We can't understand each other when we talk because we're like, is that an ink pen or a fountain pen or what kind of pen are you talking about?
It's a bit like Chicago has an accent like this. Like
They've got a very local accent.
I don't have one. Like
Yeah.
the AVE sound is very emphatic.
Right.
So
Right.
I have to,
So I had to learn not to say cement, and for the longest, or cement. Cement. And I mean, he fell and hit his head on the cement. I mean, it was just a natural way you talked. And so what you would hear me do is he fell and hit his head on the cement. And you'd hear my heads spinning as I looked up a different sector and replaced part of my vocabulary with, cement. And so that's how I learned to say cement, was by, always intoning it that way.
you have to, you have a different lexer in that, and you've got a speech cartridge. Speech
I had
cartridge.
I had to override the bad sectors in my hard drive. Yeah.
So-
Of course,
so what
back in my day, it was a floppy drive, not a hard drive.
Of course. So what are we looking at there on the C128 presentation? You said there were some questions that came in last week when we were discussing this. And now the unique thing about the 128 was it was both a CPM supported Z80 machine and a C64 all on one board, which to me is just mind blowing. That's like today putting a PC with an x86 64 processor and an IBM Power architecture, RISC CPU on one board in a workstation that could do crazy stuff. Which, of course, we wouldn't do that today because we have high performance computing in the cloud. We have all these other things at our disposal. You could even, if you really wanted to go gangbusters, you use GPU and CUDA. So, but this is just really a massive achievement.
We knew it could work because there had been a Z80 cartridge for the Commodore 64, but it had problems. And it's not worth going into today what the problem was, but it had an issue, and everybody thought it was a timing issue, and it actually dealt with the way you paused the Z80, and I'll talk about pausing it here in a second. But we knew it worked because we had a CPM cartridge for the C64, and then I have in my collection somewhere, I found that the guy who did our CPM cartridge copied the architecture of it from an Apple II board. So there was a Z80 card for Apple IIs, and they were a card-based computer. And the card was made by Microsoft, of all people. So Microsoft did hardware, back in the early 80s. And so we copied Microsoft's board for the Z80 for the Apple II, and that's where our CPM cartridge came from. Now, the CPM cartridge that worked poorly at times in the C64 hardly worked at all in the 128. We had two cartridges in the engineering lab, and of those, one didn't work at all. So out of my sample of two, I had a 50% failure. So I don't know what the real failure rate was, but that was good. Bad enough for me. I knew that I had a decision to make. That was, can I make the CPM cartridge work, or do I move the functionality onto the main board? So I moved it to the main board, and in doing so, I saved 1.5 amps of power from the power supply that would have only been used if you had a CPM cartridge plugged in. And so that was significant. That was $1 I wasn't throwing away on every unit. That's $5 million we saved by building the Z80 onto the board. Yeah, more than that. More than that by the time you get 1.5 amps and the sizing and everything else. So what makes the Z80 different than the 6502 is the 6502, as we talked last week, says here's addresses. Let me lower this for a second. Says here's on every clock it goes here's addresses, here's data. Here's addresses, here's data. So it does one instruction fetch per clock cycle. Well, that makes it real easy to interlace with the VIC chip, because we had this known times. Let's see if I can see if I can get the mouse to appear here.
So this is the trick, because you can actually gate 2 Z80 clocks. Because the Z80 clock frequency was double the 6502.
It was 4 times. Normally it was 4 times. It was a ratio of 4 to 1. So a 1 megahertz 6502 ran the same speed as a 4 megahertz Z80, because it took between 3 and 4 cycles. Yeah. Right. It took 3 or 4 cycles per instruction. So knowing that, what we would do is we would pulse out 2 Z80 clock cycles during the VIC time. When the VIC is on the bus, we let the Z80 run, but we don't let it on the bus. We just let it do some thinking. And then we stop the Z80 clock, and we wait for a memory cycle. And that's where you see the Z80 address here and then the Z80 data. So this is, instead of the 6502, we would have the Z80 on during this time. And then it would go pulse, pulse, wait, pulse, pulse, wait. And if that sounds clunky, it kind of was, because you might have needed the memory pulse here. So you would go pulse, wait, wait, memory cycle. So you'd throw away a cycle. There'd be other times where it would go clock, clock, and it only needed one more clock to, for a memory cycle, but whoop, wait till the next cycle, one more clock, and then it'd have to wait for memory. So it was less than 50% efficient, and still kind of rocked by the time it was over with.
Yeah, it was a pretty amazing economy sort of way to do that.
Yeah. So here was, then to drive the Z80 clock was a special requirement. NMOS will only drive up to, like it's shown here in blue, it'll drive to 4 volts, and then it will have an RC tail up to 5 volts. Well, the spec for the Z80 is it had to get to 4.9 volts in 10 nanoseconds.
Yeah, it needed a real strong rising edge.
And there was a clock chip, a clock buffer made for the Z80. The Z80 cost me less than $1. It was like 80 cents, right? And it was that much because I had to buy it. I couldn't make it myself. But the clock driver for it was $2. Wait a minute, you want me to spend more than twice the amount because it had a bootstrap and do everything to try and pull it all the way to 5 volts in 10 nanoseconds? That was hard to do back in the day. So they had probably had PMOS outputs on it or something. So what I had to do was I wasn't going to pay $2 for a driver chip. I just that was all the savings from the power supply and more I'd waste on a part not even made by Commodore, right? Well, that means if there's a shortage of them, the 128 stops rolling.
Yeah, you don't want that. It's bad.
So so here's what we did. Let me see if I can pull it up here.
So you buffered it with a open collector or open drain 7407.
Right. So that pulls to ground right away. This one right here. Let me get my mouse. This one right here goes bang, pulls it to ground. Right? No problem. We got the 0 going real fast. But when it went to go high, I would get this RC tail. If I was using a 5-volt pull-up, it would always do an RC tail on it.
Right.
So what I did was
overdrive the transistor with 12 volts.
Yes.
Because So the 740, this is why you need open drain logic sometimes, right?
Right,
'Cause you
right.
interface
Open collector,
different.
right? And the 7407 is a high voltage open collector. It's either 15 or 30 volts. My memory is it's 30 volts. So the 5407 is 15 volts, something like that. But it's a high voltage. And so I'd let it go winging all the way up to 12 volts, like the blue here shows.
Yep, and
And
push that.
and yet the
emitter
transistor is
follower
hooked to
into
5 volts.
saturation.
Yeah. Right.
Yeah.
So what happened was it was an emitter follower until this voltage got to 5 volts minus 0.6 or 0.3 or something. And then it would flip the polarity on the transistor and it would dangle upside down because its base is now at 12 volts and its collector is at 5. And I had never seen that done before. And I walked around everybody people I liked and people I didn't like, people I trusted and even people I didn't care about their opinion. But I figure if they can poke a hole in this, I need to know this. I talked with people that knew how to design transistors, right?
You must have been concerned that the PN junction from the base to the emitter was going to pull the emitter up to 12 minus 0.65.
Or crack. Or inject carriers and go bad. And my fear wasn't that it would break right away, because we'd know, we were going to cook these things. My fear was it'd break after a couple thousand hours and break 100% of the time.
Suddenly there's a recall, and you've got millions of product out there, and
Bill Hurd's out on the street with egg all over him. Yeah, so this was by far the riskiest thing that I did while working at Commodore. Was I went with that circuit that you see there.
Yeah.
And I'll tell you, all my electronics
worked.
What?
Other than just waiting and seeing, how did you prove?
Well,
that it
if you saw
worked
if you looked at the waveform, it slammed to 5 volts. It actually slammed to like 5.3 or something like that. It went wham. It did exactly what I predicted it would do.
Right. And then using your knowledge of transistors and transistor signal models.
Right.
Having a base at a much higher voltage than both collector and emitter.
It looked like a diode at that point. It stopped being a transistor and it started to be just a snubbed off, diode. Mm-hmm. And again, the base collector diode is.
Were you driving it into avalanche or
no, just driving it. No, it just became a forward biased resistor. And that's what
right now. It's been so long since I studied small signal transistor theory. I need to refresh my memory on that.
Picture the PN junction right here. Picture it like a 1N914. Once this went higher than this, it would clamp to the 5 volts. So this would be a resistor to a diode to 5 volts. And then at some voltage below that would be the clock. So it's strange enough that if I tell you all my electronics career, I've hooked electronics together. This is the one thing I invented in my whole career that I've never seen since then, where I took a transistor and some open collector gates and I made a high voltage driven 5 volt emitter follower that goes into a diode clamping after 5 volts. So it is a strange circuit, and it worked. And I swear to God, I would sit there and wait. I waited for the news that I totally fracked up, that I had just blown the entire thing, and that it's way too late to recover the 128. They have to, just set it off to the side and fire Bill Hurd. That's what I thought would happen.
Well, I'm glad it worked.
It worked. It worked. And we did thousands of units and it still worked. So my challenge. Oh, and by the way, I gave myself, when I did that, I gave myself the nickname after that weekend that I did this. I started calling myself Captain Klooge, because it's a kludge.
But this is hardware hacking. This is the true meaning of hack. And it's sometimes the hack becomes. It's something that starts as a hack becomes common engineering practice because it works. And engineering is all about being pragmatic, right?
Right. So a person from Bard from last week just said this is exactly what he was asking about last week. So Yeah, all the reason. Tell your friends to come hang out. We'll have 21 people watching the show instead of 20.
Yeah. Well, we want to grow our viewership. We keep saying we need a producer. I think the actual production you've got dialed in now. It was a bit rough at the beginning. What we don't have is we should be marketing through podcast apps and filling in all the details on the YouTube,
doing all that social media stuff,
so that it gets indexed, by Google and all that. And it's hard to set aside time for that,
right?
When we barely have time just to do this each week. Right?
And it's hard for me to write the description ahead of time because you and me don't really know what we're talking about till we start talking.
Yeah, I just need to.
And we don't go back and then summarize it, because after we're done, we're like, oh, I'm exhausted.
Well, if you give me permission, Bill, to put the summaries in your YouTube channel, I would. Or I could just.
Well, I almost asked you for two. Yeah, I almost asked you 2 weeks ago the software you were talking about. I was going to ask you, give me a 2-sentence summary of the simulation software that you showed us.
Oh, I was
that field strength stuff.
Field solver. That was Ansys, which is a really high end. It's really the flagship, best of the best. And I happen to have access to it right now for something that I can't really share any details of. But normally I try to use free tools on things like this because I know that anyone could have access to them. I will say this, if I had a student ID from a university or college, Ansys does have student versions of HFSS. Right. And for anyone who's watching, if you're a student, absolutely get your hands on it. It is exceedingly powerful, but the really nice thing about it is of all the different simulation tools I've tried over the years I'm not talking SPICE simulation, I'm talking electromagnetics. The value in those tools like that is not only the speed and performance, but also the user interface is just so much more easy and straightforward.
Yeah, right.
So if you're a student, check them out. They're not sponsoring us or anything. Since you asked, I was answering the question.
Right, right. So somebody posted that something I heard yesterday. By the way, we did a broadcast with TPUG, the Toronto Pet Users Group, and they're going to try and post it on a YouTube channel. I'll post that in our Discord channel, which actually maybe I'll post Discord channel to the chat here. But Clive Sinclair, Sir Clive Sinclair died yesterday, or at least I heard about it yesterday.
Oh, he must have been quite old. He was a fiery character, that one. Have you watched there was a dramatization of the founding of Acorn, which became ARM.
No, I haven't seen that.
It's brilliant. It's brilliant. I've got to remember the name of it, but basically they were making I wouldn't even say docudrama, it's more of just drama. But there was a mini series that was the story of how some engineers left Sinclair and formed Acorn. And Acorn won the contract for the BBC to produce computers for school kids. And that was the beginning of what eventually became ARM, which is everywhere now.
Yes.
ARM used to stand for Acorn Risk Machine.
Oh,
but they renamed.
Did I know that?
They renamed it or rebranded it sometime later when it started taking off, and when they shifted gears and stopped being a computer company and started being a fabless semiconductor company that would license out its IP.
when they shifted into that, they renamed it Advanced Risk Machine, and that's what ARM stands for now. But it started life as Acorn Risk Machine, which was not the first computer. The first computer they built was the BBC Acorn, which I used when I was in school, because the school I went to had a low budget for a computing lab. So they went out and bought old used 8-bit BBC Acorns from a state school, a state-run school that had better budget than, oddly enough, the private school I went to. So the first computer lab we had was BBC Acorns, and they were 6502.
Okay. Okay, I didn't know that.
Not nearly as good as a Commodore 64. We were all like whining to the teachers, "Why couldn't you have gone out and bought Commodore 64s?"
Wasn't Ohio Scientific like an Acorn? They were kind of the American version of an Acorn. It was 6502 based.
I've never even
simple
heard of them.
computer.
Yeah, never even heard of them. BBC Acorns, they had some things going for them. They booted up in a basic. They had chunky character-based graphics. They were a little bit like the TED, you could say, in equivalent functionality.
Right, right.
And so there were a few games with some basic graphics, but they weren't. They were super chunky. They didn't have enough. They had, most of the ones in our lab had only 32K of memory, not 64, and they had Logo. So they did have graphics in that regard. So we learned to program in BASIC and Logo, which was cool. Logo is the language that's all about driving a robotic turtle. And it was invented by universities for teaching basic programming and control systems in the 70s.
Yeah, I remember turtles.
And they had turtles that had an umbilical cord, cable that ran to an output on the mainframe, and they programmed in Logo, and it would make the turtle put a pen down and drive a certain distance, and then pen up, and then change direction. And so we didn't have turtles, but the logo on the BBC Micro would draw on the screen. So that was fun. And
we had a turtle in the R&D lab. It was a semi-sphere of plexiglass.
Yeah.
It had two big wheels and a little trailer wheel, kind of a little caster wheel.
Yep.
And as you said, there was a place to put a pen in it.
And the difference now, like people do similar things now. They do it with a Pi or an Arduino.
Yeah.
And it's completely autonomous and has its own power source. And you send instructions to it, and it'll do the thing. But what's the point of all that? So BBC Micros were 6502 based, simple-ish, less capable than a Commodore, but still pretty good. And later on, they evolved into the Archimedes, and the Archimedes was the company Acorn made its own chip design, and that was the first Acorn RISC machine, and they created this computer called the Archimedes, which never got real traction outside of Great Britain much, and some Western Europe had them. But then they switched gears and realized they could license their ARM chip IP to others, and it grew from there. So anyway, we're always talking history, but I like the history of all this stuff. I find it fascinating. Yeah.
Yeah, so here is an Ohio Scientific. So it was your standard, like, kind of clunky looking, but I knew somebody that had one of these, and it was a typical computer for the day, and would have run basic. Look at that board. That is such a typical board for the day.
Yep, it's very similar to what the BBC Micro looked like on the inside.
Right. And you mentioned, not being 64K with the computer, the Acorn you were talking about. What made the C64 unique, other than sprites and whatnot, is we were the first computer that could bank out almost everything and give you all 64K. I don't think an Apple, my memory is, and I'll probably get thrashed for this if I'm wrong, was the Apple could only ever really, of the 64K, you could only ever get to 48K of it. That there was some things that stayed in there no matter what.
Yeah, like
We had
drivers
it.
and
Yeah.
memory mapping for that was the problem. So you had to with 6502 and Motorola processors, the architecture was von Neumann, not Harvard. So you
Right.
had one memory space and everything, all your IOs got mapped into it. Whereas with the microcontrollers that came out at the same time, 8051s and their derivatives, they're Harvard architecture where your instruction and microchip picks are the same in AVRs. Your instructions have a different memory map that's separate
Right.
from your main memory. So
Right.
your data goes into your read-write memory, and your instructions come from a separate memory. And so you don't have to divide up your memory map if you don't want to, like
Right.
that, because
I
IO can be separate as well. So
is the Z80 Harvard mapped? I'm trying to remember.
it's
I'm
von
trying.
Neumann. It's
It's
von
von
Neumann
Neumann.
as
All right.
well. Yeah,
Because
but
I couldn't
it did
remember if
have
we
a
just
dedicated
ignored the
IO
difference.
pin. Yeah.
Yeah, because we had mem cell and IO cell, and I just was trying to remember if we just ignored it or if it was actually a von Neumann machine to begin with.
So for normal Z80 architecture, it's von Neumann. So they also you had to use up some of your memory space for memory mapped IO.
Okay. Yeah, I couldn't remember because the other way we would have done it was we would have just only done memory calls and then jumped to the kernel for IO. And that's pretty much what the CPM cartridge does. CPM doesn't read and write to the disk. It calls kernel routines in the 6502 that are already written. Go get me a sector and put it here. And the 6502 would go and do it, come back, and then the Z80 would continue going on. So, hey,
Yeah, so
somebody
you
asked
already
it
had
if
a hardware abstraction layer as well in doing all of that. That's what that is.
we were abstracting the hardware to some degree. We called it a kernel back then, but so somebody asked, is it Micromen is the
Yes,
TV
that's
show
it.
you were talking
That's
about?
it. Micromen. That's brilliant. I love that one.
I'll have to
Great,
check it
great
out.
show. Yeah.
Hang on a second. With the Von, like the Z80. Yep. They definitely say the Z80 is Von Neumann. So now, when the 8086, that was, even though it ran the Z80 like instructions,
Completely
wasn't
different though. Yeah, non-compatible.
it was
at all.
completely different. That was my right. Even though they had the same opcodes, it was completely different.
Well, they shared. No, they didn't. Even the mnemonics weren't the same. The
The
8085 was machine language compatible to a degree with the Z80, and that's why both were in the CPM era. You had Intel 8085s running CPM, Intel 8080s, which is the predecessor to the 85. But the 86 was a completely different architecture and a different instruction set. But the Intel programming manuals used similar mnemonics like MOV, whereas...
Well, so here's why I thought this was one time we didn't have a Z80 manual and we needed the Z80 to boot up first overnight. And I called Von Ertwein, who did our CPM, and he wasn't there. And I said, I need a hand. And I got hold of his wife, Kathy, and I said, I need the codes to write, jump. And she read them to me. She said, I don't have a Z80 manual, but I've got my Intel manual. And she read me the opcodes, the actual, 0502 type things. Mm-hmm. And I punched those into a Data IO 29 by hand, made that part of the EEPROM do the Z80. And all the Z80 did was boot first and then jump to 6502 mode. And she pulled it out of an Intel manual. So I knew at some time I would have known that distinction between those two families, but I can't remember 40 years later.
That was the 8085 and Z80 were largely compatible. Both ran CPM. Right. Yeah.
So look at the time.
How does this happen? We've hardly gotten to anything technical today. Well,
yeah,
except your Captain Kluge awesome hack.
Yeah, and even the data river and stuff. That was, whoa, hey, Phantom Key.
So
there's a lot.
We were going to talk about bootstrapping, but we didn't. We still, for weeks we've been threatening to get to that, but never quite got to it.
Let's make that our primary for next week. Let's do that.
We'll try.
We'll
Yeah.
talk about how to bootstrap a JFET amplifier and what bootstrapping is and why it's important and useful.
Yep. It's actually
So cool.
Well, there's analog circuits that use it in audio, but there's also it's pretty frequently encountered in switching power supplies as well.
And I'll tell you that it's also how one of the ways that, so the Z80 clock I was talking about, we did try and do that in NMOS, and it failed. And the guy, Dave DiOrio, came to me. I said, here's what I need it to do is this 4.9, can you do it? He said, yeah, I think so. And when we got the chip, I tried it. I went to him and said it didn't work. And he got back to me. I mean, he was a straight up guy. He took hours and he got back to me and said, we're not going to be able to do it. And I know he had tried to do a form of bootstrapping. He tried to make a voltage doubler to pull the inmost past 5 volts. And he probably got into forward conduction somewhere, you know, like the JFETs that form around the pads that end up being the ESD protection, stuff like that.
Yeah.
Probably something went into forward conduction that couldn't be changed. It was probably physics that defeated him on that. And that's why I said, great, thank you for telling me. And that's where I came up with that transistor circuit, literally that same day. It just sitting there scratching. It was by 1 in the afternoon where I started working on that. I remember because it was morning time was working with Dave, and then the afternoon was going, how the heck can we make this work without buying that stupid $2 part?
It's too easy to think $2 isn't much, but it is. When you're making millions
5 million
of something,
yeah.
it's a problem. Yeah.
So Board corrected me on his name. I tried to throw an AORD in there and make him Board, but he says pronounced Board, but he thanked us for the stream. So there was a Commodore fan out there after all these years.
Thanks for joining us. And again, if you
tell your friends.
You have other engineer co-workers or anyone else who is into this stuff, like we do this every week pretty much. Sometimes I can't, and then Bill gets a guest. Like we've had some really cool guests too, like Alan Wilkie and now I forgot her. Yeah, you even had Sophie Kravitz one time, didn't you?
Sophie, that's what I was trying to think of.
Yeah.
So,
and,
if people have something you want to hear, by all means tell us, because this entire show today was because somebody had told us about, you know, what they wanted to hear. Also, Mike Fikes, we've had him on. He went on he steps in for us, and he went on an equipment purchasing fee, spree, and he's always got fun stuff to demo.
Oh, I'm envious of his test lab. But
somebody
he's
just said
where he needs all that stuff right now for launching products to market. So
Yep. So John mentioned that he just got an MOS shirt, and I almost wore my MOS shirt today, but I'm saving it now for VCF. I had gone and printed an MOS technology shirt with just the logo I got off the internet and went to Custom Ink or one of those places.
Yeah, we need I need to get a chicken head logo shirt one of these days soon.
Yeah, I'll get the one with the crossed eyes. It's so. Well, Ben, my friend, it was good talking with you again, and we will see you next week.
Yeah, you too, as always.
All right. So, bye, everybody.